In the earlier session, we have seen the working of the SR flip-flop using cross-coupled NOR gates and how to derive the characteristic table, excitation table, and the characteristic equation has been seen. In today's class, we will see about the gated flip-flops, or you will see the gated latches like SR latch. So now we will analyze using a cross-coupled NAND gate. Okay. So when you go for the simple RS flip-flop, you have two inputs R and S, Q and Q bar. Okay. Now before analyzing the truth table, we should analyze the NAND gate operation. What is NAND gate operation? When I have my 4 inputs from the NAND gate, what is the AND gate means? When both the inputs are 1 only, output will be 1. So 0, 1, 1, 1. But here we are going to take a NAND gate. So it is 1, 1, 1, 0. So when you analyze your NAND gate, it is understood that when either one input is 0 or both the input is 0, the output is 1. Only with this basic concept we are going to proceed with. Now let us take the first condition 0, 0. So whenever I am going to give 0, 0, what will happen? 0, 0 whenever I am giving, you know 0 means 1. So both the inputs cannot be same because Q and Q bar are complement to each other. So it is a invalid condition. Now we will move on to the next case when my set input is 1. What will happen when my set input is 1? Generally you should know that it will set the flip-flop, so your Q will be 1, right? So here whenever one input is 0, irrespective of the other input, your output is going to be 1. So this 1 comes here, 1, 1, the output is 0. In other words, whenever I am going to give my set signal as 1, my flip-flop is going to set. So this is done with. Now we will go for the condition when the S is 0 and the reset is 1. So when I say this condition, it is understood that when I am resetting the flip-flop, when I am giving R as 1, it will reset the flip-flop. That means Q output will be 0. Let us analyze how it is working. Now what is the thing? Out of this 0 you have here. So when 0 means automatically here the output will be 1. This output will be traversed over here. 1, 1 means it is 0. Okay, this 0 comes here. This 0, 0 means it is 1. So what is the condition here? If I am going to make my reset as 1, my output is going to be 0. So this condition is also going to be verified with. Now we will take the last condition whenever I am going to take my condition as 1, 1. Okay. So here what happens? Whatever is the previous condition, that we will retain. So because 1, 1 we cannot predict your output. Now this 0 will come here, 0 into 1, it is 1 here, and 1 when proceeded with, you are getting 0. So what you are going to see with respect to this, the previous condition was 0, 1 and this condition was also 0, 1. So this is a no change condition. So here as usual set and reset remains the same. Okay. Whenever I am going to use the NOR gate and the NAND gate application, 1, 1 was a invalid in NAND gate and 0, 0 was an invalid condition and 1, 1 is a no change condition. Now this SR latch we will see. I have told you what is the difference between the latch and the flip-flop. Flip-flop is one in which I am going to give the clock pulse. When I am giving the clock pulse alone, the data from the input will change to your output. In that case, I will put here one more table and I will put the clock pulse condition. Only when the clock pulse is there, the data from the input will be transferred to the output. Okay, so that comes whenever I am going to include this, it is called as a clocked SR flip-flop. Okay, and if it is going to be this, clock triggering can be anything. It can be a edge triggering or a pulse triggering or a level triggering. Okay, so now we will just analyze how to draw the clocked flip-flop and how this clocked flip-flop is going to differ from the latch. Okay, for this what I am doing, I am just adding one more NAND gate. Okay, and whatever I am going to do is, I am going to put a clock pulse. So what is the modification I am doing? I am just putting a 2 NAND gates. Let us name it. Okay, 3 and 4 NAND gates are the newer ones, and R and S inputs are there, and I am applying the clock signal. Okay, so the only difference is when I am going to apply the clock signal, it is going to act as a flip-flop. Whenever if I am going to change this clock pulse as enable, then it will act as a latch. What is a latch? Even this is a latch, that is the data is very sensitive to the set and reset signal. Then and there it will be going on changing the output. Immediately it will get changed. Okay, at all instants of time. Whereas when you give a clock pulse, only when you press the clock pulse you will get your output. So that is a difference. So this latch you can control to an extent by using a enable pin. Okay, whenever I am going to give the enable, the latch will work. Enable is 0 means the latch will not work. Okay, now let us see the condition. Now what is the condition? Suppose my clock pulse is 0. What will happen? What is the condition when one input is 0? The output is 1. So when my clock pulse is 0, output is going to be at 1. But when my clock pulse is 1, only when my clock pulse is 1, whatever is the reset or set signal, depending upon my truth table, will be able to reach the output. Okay, what are the things we have seen so far? So we have just analyzed a SR latch. Okay, then how I am going to use it as a clocked RS flip-flop. Okay, only when the clock pulse is 1, whatever your input data, it can reach the output. If it is going to be 0, what is the general condition? 0 means 1. Both the states will be at high state. Okay, now the same circuit, edge triggered, now SR latch. Okay, I can also write it as a edge triggered SR latch. Now this I am going to convert into a enable. So what I should do, only the concepts you should know. What are the changes I am doing, you see. So what I am doing, if I want to change it, all the things now, okay, so this is a clocked, that is if I am going to give a clock pulse, it is called as a clocked flip-flop. Now if I want to say it as a latch, okay, SR latch, in that case what is the modification I am doing? I am going to give a enable pin, and instead of clock pulse you put a enable pin here. So when the enable is 1, okay, what happens here? The same concept. Only when the enable is 1, the data will be transferred to the output. When enable is going to be 0, so you cannot get any data. The output remains at 1. But when enable is going to be 1, in that case output, that is the data from the input will be transferred to the output. Okay. So this is the concept today. We have seen how to work your RS flip-flop with your NAND gates, how you can convert into a clocked RS flip-flop, that is edge triggered flip-flop, and the same thing how you can convert into a gated SR latch. Thank you students. In the next class we will see about the D flip-flop. Thank you.